Welcome to Kovach Chemistry. Today we're going to start with a little joke. What is a chemist's favorite plant? That's right, you guessed it, a stoichiometry. Now that we've gotten that taken care of, we are going to review what you students should already know about stoichiometry. And of course, stoichiometry is based on a balanced chemical equation. How do we balance chemical equations? Well, remember that the subscripts should never be changed when balancing an equation. That's point number one. Coefficients should change only the amount of the substance, not its identity. Remember, if we change the identity of the substance, we would change the subscripts, and then we'd end up with something like peroxide as opposed to water. Physical states are often indicated as S, L, G, and AQ. I hope that you remember what those stand for. Have you remembered? S is solid, L is liquid, G is gas, and AQ is aqueous or aqueous, depending upon your preference. To indicate heat added, a Greek letter delta may be written above the arrow. Does anyone remember what the delta looks like? Well, here you go. It looks like, yes, a triangle. Now let's discuss types of reactions. The first type is something called synthesis, in which two or more substances give you one product. Then you have decomposition, which is really the exact opposite of synthesis, where you take one thing and break it into multiple other things. Thirdly, or number three, we have combustion of hydrocarbons. And if you have complete combustion, you're going to get carbon dioxide. If it's incomplete combustion, it's going to be carbon monoxide. The fourth type of reaction is something called neutralization, which occurs when an acid combines with a base to form an ionic salt and water. The fifth type of reaction are redox reactions, which occur when electrons are transferred from one reactant to another. We'll talk more about redox reactions later. That is the one type of reaction we did not cover in honors chemistry. Precipitation reactions occur when a solid is produced, usually in solution. Next we have percent composition. Now this is used when you want to discuss what is the exact amount of carbon, say, in carbon dioxide or something along those lines. So the procedure for doing that is to divide the total mass of the element by the total mass of the compound and multiply by 100 if you're given masses. If you're not given masses, then you would use the molar masses from the periodic table, a portion of which you see displayed here. When we are calculating in AP chemistry, you always do the following two things. Number one, you carry one more digit until the end than you would need. Then you round to the correct number of significant figures. And yes, we are going to use significant figures all year long. I know you're happy. Number two, use the molar weights listed on the AP periodic table. I believe this is a section from the AP periodic table, but never fear, you will always have a copy of the AP periodic table. You could lose points if you don't use the right number of significant figures, and so we want to avoid that and just get into good habits from the get-go. And here you have my favorite picture I found this summer. So y'all can sing along if you like. I think I'm going to avoid that on this video, though. Hope you enjoyed this slide. Here we have a familiar mole diagram. And you should remember this from last year, where we looked at the molar mass being the conversion factor between mass and the mole. Right? And also we could look at converting from moles to particles, and we're going to use whose number? Yes, that's right, Avogadro's number, 6.02 times 10 to the 23rd. And then we also could convert from moles to volume, or from volume back to moles, but remember that it's got to be gases at STP, and you would use then your molar volume here, 22.4 liters per mole. Okay, so now we're going to practice. It says, without using a calculator, arrange the following in order of increasing number of carbon atoms. So we have 12 grams of carbon. Well, you might recall that 12 grams is approximately the atomic mass of carbon, so that means that we have 1 mole of carbon, and then we have, it says 1 mole of C2H2. So you also might recall that in order to determine the number of moles given in a formula unit, you would multiply by the number that is the subscript for that element. And so since the subscript for carbon is 2, that means that we have 2 moles of carbon in 1 mole of C2H2. All right, so so far we have 1 mole of carbon and 2 moles of carbon in C2H2. And then we have 9 times 10 to the 23rd molecules of CO2. Well, 9 is approximately 1.5 times 6. Hopefully you all can do that type of math in your heads. If you can't, you need to do a little practice. Because remember that on the test in May, you're not going to have a calculator for the multiple choice. So just a little warning. All right, so anyway, so 9 is 1.5 times 6. Now, why is that important? Well, if you have 6 times 10 to the 23rd molecules, that would be 1 mole. So if you have 9 times 10 to the 23rd molecules, that's 1.5 moles. And, of course, there's 1 carbon in CO2, so we would multiply by the 1 and end up with 1.5 moles. So what then is the order from least to most? Well, so we would have the carbon, and then the carbon dioxide, and then the C2H2, which is acetylene, which is the fuel that is found in blowtorches. All right, so go ahead and do the second problem as a practice problem, and we will go over the answer in class. All righty, so let's see, do this now. All right. Okay, so now we're going to do some more practice. Number 1 here, how many oxygen atoms are in 0.25 moles of calcium nitrate? Well, the first thing you might need to know is, what is the formula for calcium nitrate? Well, do you really need to know that to answer this question? Yes, you actually do, because you need to know how many oxygen atoms are in the formula for calcium nitrate. All right, so calcium is Ca, very good. Nitrate is NO3. And then let's see, we're going to have to remember the charges for these, aren't we? What's the charge on calcium? Well, it's +2. How about nitrate? Yep, -1. So now if we crisscross, or we determine that the number of positives has to equal the number of negatives, then we would end up with the formula being CaNO3 2. And remember that we don't include the charges in the formula. So there's the formula for calcium nitrate. All right, now let's proceed with the problem. We have 0.25 moles of calcium nitrate, and so that means that the first thing we're going to want to do is to convert moles to particles. And how would we do that? Well, remember that we're going to multiply out and divide in. So we're going to multiply by Avogadro's number here. And then we're going to end up with, what kinds of particles? Well, technically, this would be formula units. Okay, right? Our favorite abbreviation. Why is this formula units? Oh, that's right. It's an ionic compound, so these would be formula units. All right, and then, of course, we want to know how many atoms specifically of oxygen we've got in there. Well, for every 1 formula unit, we would have 6 oxygen atoms. So if we do all the multiplying here, and we could approximate, but I will go ahead and write down the actual number here, which would happen to be 9, well actually this is still approximating, 9 times 10 to the 23rd atoms of oxygen. Alright, so there's that problem. So let's see if you can figure out this problem. Okay, do this. Now, so pause the video, go ahead and do it. All right, and now we're back. So now we want to do nitric acid molecules in 4.20 grams of nitric acid, and then how many oxygen atoms would that be? All right, so this is a two-step problem. So the first part, we start with 4.20 grams, and that would be of nitric acid. I'm going to have to figure out that formula as well. Well, remember that it comes from nitrate, because remember my handy-dandy mnemonic device was I ate something icky. And so the ick, the acid, comes from the ate. So we know that it's got NO3 in it. We also know that NO3 is -1 from our earlier problem. So that means that we need to balance that out with 1 hydrogen. So there's a formula for nitric acid. So if we want to know how many molecules, we're probably going to have to convert grams to moles. And how are we doing that again? Oh, that's right. We're going to use the molar mass from the periodic table. Oops, did I make a mistake? Yes, I did. 1 mole goes on the top. Why did I make a mistake there? Somebody think about that. What's the reason? Oh, that's right. You're supposed to be able to cancel. And so we need to make sure that grams goes in the denominator of our first fraction there. So 4.20 grams of HNO3 divided by 63.02 grams of HNO3 is going to give me the number of moles of HNO3. Then I would need to multiply that by Avogadro's number, and that would give me the number of molecules. Why is it molecules here? Anybody remember? Oh, that's right. Molecules are for molecular compounds. And since HNO3 does not contain a metal, it must be molecular. So these are molecules. All right, so if we do our multiplying and dividing, we should get 4.01 times 10 to the 22nd molecules here. All right, now, what would I do to figure out how many atoms of oxygen I'd have here? Well, let's think about that. Notice I'm out of room here on my slide, but that's okay. What we would need to do is multiply by what number, class? Well, we would probably need to multiply by the 3 here, because there are 3 atoms of oxygen in every 1 molecule of nitric acid. So if I multiply by 3, I'm going to end up with 1.20 times 10 to the 23rd atoms of oxygen. And then someone is going to say, Mrs. Kovach, 3 times 4 is 12. Yes, it is. So that would be 12 times 10 to the 22nd. But is that in correct scientific notation, class? No, it's not. So in order to make it in correct scientific notation, you would want to move the decimal back to the place between the 1 and the 2. And if we do that, then we need to make the exponent of 1 notch larger because we have made the coefficient smaller, so the exponent needs to get larger. All right, so if you can't remember some of that math, make sure you review that or come and see me. Thank you. See you later.